All right, let's look at number 8. They ask us to give 3 additional pairs of polar points for the point 3, 2 pi over 3. This is another one of those things that if they had asked me to graph this, I might want to find multiple points first, and then I can just see which is the easiest one to graph, like we were doing on number 7. It also says to be sure to give at least 1 point with a negative r value. So these are our formulas from our formula sheet, that if we want to find additional names, all we need to do is take our theta and find coterminals. So we're going to add 2 pi and subtract 2 pi. So if we take 2 pi over 3 and we add 2 pi over 1, we would need a common denominator of 3. So that would be 6 pi over 3. So 2 pi and 6 pi gives us 8 pi over 3. If we were subtracting 2 pi, then that would just be subtracting 6 pi over 3. So 2 pi minus 6 pi would be negative 4 pi over 3. And then to give the negative radius, remember that you just add 1 pi to the angle instead of 2 pi. So I'm going to switch my radius of 3 to negative 3, and then I'm going to add 1 pi. So 1 pi would be 3 pi over 3, and so 2 pi over 3 and 3 pi over 3 would be 5 pi over 3. If I graphed those, they would all graph as the exact same point. Now on your test, I reminded you that at this point you need to switch to radian mode on your graphing calculator. And we want to convert 3 2 pi over 3 from polar to rectangular form. On your formula sheet, it tells you the formulas to do that are x equals r cosine theta and y equals r sine theta. So r is 3 and theta is 2 pi over 3. R is 3, theta 2 pi over 3. And cosine 2 pi over 3 on our unit circle on our formula sheet is negative 1/2. So 3 times negative 1/2 would be negative 3/2. Again, r is 3, theta is 2 pi over 3, so look up sine 2 pi over 3 on your unit circle on your formula sheet, and we get square root of 3 over 2, and 3 times square root of 3 over 2 gives us 3 square roots of 3 over 2. If we want to go the opposite way and we want to convert from rectangular back to polar, on your formula sheet it tells you to use x squared plus y squared equals r squared, and tangent equals y over x. So x is negative 3, y is negative 3. So let's put negative 3 in for x, negative 3 in for y. We'll get 9 plus 9, or 18, is equal to the radius squared. Take the square root of both sides, and we'll get r is equal to the square root of 18. Square root of 18 would be 9 times 2, so square root of 9 would be 3 square roots of 2. And then for tangent, tangent is y over x, so y was negative 3 and x was negative 3, so we're looking for where tangent equals positive 1. I did put your tangent values on your unit circle on your formula sheet, so look on your formula sheet and see where tangent is positive 1, and that ends up being at pi over 4 and 5 pi over 4. So the way that I know which one of those it is I go back to the original point and see what quadrant I'm in. Since this is third quadrant, then I have to choose 5 pi over 4. If both of these had been positive, if this had been positive 3 and positive 3, that would have been first quadrant, and I would have chosen 1 pi over 4. Then for number 11, they ask us to graph the polar equation. Now, because you have your graphing calculator for this test, my suggestion would be the very first thing I would do is I would put it in my calculator just so I know what I'm trying to get and what my graph is going to look like when I'm done. So the way we do that, remember, is make sure you're in radian mode and make sure that you're in polar mode. When you do that, when you go to y equals, then it says r equals. So you can type in 2 minus 3 cosine x. When you type your xt theta button right beside your green button, it'll put the theta in there. And then I just had mine set on a zoom decimal, but you can use whatever you'd like to. And so we're able to see our graph before we get started to know what we're trying to get. All right, so then you need to be able to complete the table, and we're using our calculator to do that. So we're just going to take 0 and put it in the place of theta in the formula. So it would be 2 minus 3 cosine 0 in radian mode on my calculator. My calculator will shoot out negative 1. All right, then I put in pi over 6, so it would be 2 minus 3 times the cosine of pi over 6, and my calculator will tell me negative 0.6. So that's how we're getting these values in the table, is we're just getting them off the calculator, and now we want to go graph them. So for the first one, we have 0, negative 1. Okay, so here's 0. A positive 1 would go this way. So a negative 1 is going to go the opposite way. So a negative 1 is going to go this way. So right here at 0, negative 1 gives us that point right there. Then pi over 6, negative 0.6. So pi over 6 is right here. A positive 0.6 would go this way. So a negative 0.6 is going to go the opposite way. So a negative, there's negative 1/2, so there's negative 0.6 right there. All right, then pi over 4, so pi over 4 positive 1 would go this way. So negative 1 is going to go this way. So again, if we are right here and we go, sorry, negative 0.1, if we go to a negative 0.1, there it is right there. So let's go ahead and connect those 3 points. We had this one, and then this one, and then this one. So we've got our curve started. And then the next one that we had is pi over 3 1/2. So here's pi over 3 right here. So 1/2 would be right here. So again, we had this point, and then this one, and then this one, and then this one. Then we had pi over 2, 2. So here's pi over 2, and we're going to come out a length of 2 for our next point. And then 2 pi over 3, 3.5. 3 pi over 4, 4.1. 5 pi over 6, 4.6. And then pi 5. And then go back and connect those dots if you haven't already. All right, then 7 pi over 6, next line is 4.6. 5 pi over 4, next line is 4.1. And then 4 pi over 3, next line is 3.5. And then 3 pi over 2, next line is 2. And again, connect those values that we just had. And then 5 pi over 3 is 1/2. 7 pi over 4 is this guy right here. So a positive value would go forward and negative value is going to go backwards. So it's going to be right there. 7 pi over 4, negative 0.1. And then 11 pi over 6, negative 0.6. So positive value would go this way. So a negative value is going the opposite way. So negative 1/2 right here, negative 0.6 right there. And then 2 pi negative 1. So 2 pi is right here. A positive 1 would go forward. So a negative 1 is just going to go backwards to this point right here. And then again, we're just going to connect those last couple of points that we just graphed. All right, for number 12, it asked us for 5 minus 2i to graph it on the complex plane and find its absolute value. So to graph it on the complex plane, all we have to do is pull out the numbers 5, negative 2, and I'm going to plot it just like that was an xy, go over 5, go down 2. The only thing is, instead of calling this x and y, we need to be sure we name it real and imaginary. If I'm finding the absolute value of that point, I'm going to start the same way. I'm just going to pull out the 5 and the negative 2. So the absolute value is the square root of the first value squared plus the second value squared. So it would be 5 squared is 25, negative 2 squared is 4. So square root of 29 would be its absolute value. That is the same thing as the magnitude that we got in our vectors, and we're going to see that in just a second. All right, for 13, we had component form of a vector. So for component form, we're going to do terminal point minus initial point. So here's our terminal point, here's our initial point. So we're just going to do negative 4 minus 3. So negative 4 minus 3, and then we're going to do 1 minus negative 5. 1 minus negative 5. So that gives us negative 7/6 for our component form, and we want to be sure that we put these markings for our vector. Kind of looks like a sideways V for our vector. Then for 14, I wanted to make sure if you accidentally got the wrong answer for this one, it didn't mess you up for the rest of them. So I gave you a different vector magnitude, or sorry, a different component form of the vector here with negative 3, 2, and I asked you to find the magnitude. All right, so magnitude is just like what we were doing a second ago with absolute value. It's just the first value squared plus the second value squared, and then the square root of that. So that would give us negative 3 squared plus 2 squared, so 9 plus 4 would give us square root of 13 for our magnitude. Now, square root of 13 is definitely not 1. And a unit vector has to have a magnitude of 1. So for the next thing, it says find a unit vector in the direction of u. So our formula for that is to take vector u and divide it by its magnitude. So we're going to take vector u, so negative 3, 2, and we're going to take negative 3 and divide it by the magnitude, and 2 and divide it by the magnitude. Now you can leave it this way, or you could also rationalize to get those radicals out of the denominator by multiplying top and bottom by the square root of 13. Then for 15, it says if vector u is negative 3, 2, and vector v is 4, 1, find 2u minus 3v and find the dot product. So let's start with 2u minus 3v. So if this is u, 2 times u is just going to be 2 times each of those values. So 2 times negative 3 and 2 times 2. So 2 times negative 3 is negative 6, and 2 times 2 is 4. Then they wanted us to find 3v. So let's do 3 times vector v, so that'd be 3 times 4 and 3 times 1. So 3 times 4 would give us 12, and 3 times 1 would give us 3. And then we need to subtract those two. So negative 6 minus 12 is negative 18, and 4 minus 3 is positive 1. And then the last thing was the dot product of those two vectors. So for the dot product, we multiply their first values, so negative 3 times 4, and we multiply their second values, so 2 times 1, and then we add the two products that we get. So we would have negative 12 plus 2, and negative 12 plus 2 would give us negative 10. So 16, we have the graph of u plus v, and they ask us to graph 2u plus v. So to begin with, if I have 2u, this is 1u, so 2u is just going to be twice as long as that. So there's my 2u. And then if I want to add v, because these are already tail to tail, I'm going to use my parallelogram method. So remember, for the parallelogram method, I use these two as two sides of my parallelogram, and I just draw 2 additional sides for my parallelogram. All right. Then my resultant is from my starting point to my stopping point, where I expanded those lines out to create the parallelogram. Now, if you wanted to, you also could do this using algebra. So, if you wanted to, you could say, hey, vector u is negative 1, positive 2, and vector v is positive 2, positive 4. So then you could just go back to doing what we were doing before with multiplying vector u by 2 and adding it to vector v, and when you do, you'll get your resultant. So that would be another way that you could do this, and this particular problem on the test is multiple choice. So here's what we get when we draw out that resultant, and again, that resultant line, just this guy right here, would be what we would be looking for in the multiple choice for our answer. Now, please don't forget that you do get a formula sheet, the same one that we've been using, and you do get your graphing calculator. So practice with those while you are working on your sample test.